All right, continuing on, just things you need to know we're going to be using. So I want you to know what the conjugate is. The conjugate of this is this. So you change the subtraction to the addition. So if I want to take this and simplify it, multiplying it by the conjugate, so multiply top and bottom of a fraction by the same thing. It does not change the expression. So I get this over this. All right, so you know that gives you a kind of a difference of squares in the denominator. So I get x minus root x plus root x, they cancel, and then I just get the -1 times the +1. That's how I get this. All right, so let's multiply by the conjugate of this, which will be the square root of x plus h plus the square root of x, all over the square root of x plus h plus the square root of x. All right, so the numerator, I'm going to keep it factored out. I'm not going to distribute the h, just going to leave it like this. And then I'm going to multiply these, so that gives me x plus h. This times this gives me root x times root x plus h, and then this times this gives me minus root x times root x plus h. Those will cancel. So I'm not even going to write them down. So then these two last terms multiplied together give me a minus x. So those x's on the denominator cancel. So I'm just left with this, and then the h's cancel, so then I just get this. All right, so again, I wanted to attack domain. You're going to see a lot of different things. So again, things to watch for: never dividing by 0, having this no negatives under the square root, and never take the logarithm of a negative number or even 0. Okay, so if I look at this graph, you're getting to recognize these graphs. So this is the top half of a circle. So the domain would be all the x's between -3 and 3, including those two. And so the range would be the y values that would be between, I guess I don't need to write like that, but I could say the y values that are between smaller than or equal to 3 and bigger than or equal to 0, right? Because I use 0 and I go all the way up to 3. Okay, so let's talk about this kind of graph. So I see I can do difference of squares in the numerator. So if I cancel the x plus 4's factor, I get x minus 4. So I'm looking at the line y equal x minus 4, except I cannot have this factor of x plus 4 to equal 0. So this thing that I canceled, this factor cannot equal 0. So what that translates to is x cannot equal -4. So I'm looking at this line. So let's graph this line. Y-intercept -4, right? That's the y-intercept. But this says x cannot equal -4. So when x is -4, I have to put a hole in the graph. So where is that y value where the hole is? So if I put x equal -4 into this, I get y equal -8. So that's the y value of the hole at x equal -4, y equal -8. Okay, so this is going to come up once you get comfortable with that. So this here is taking the absolute value. So the domain, oh, I'm sorry, I didn't answer the question for this one. So the domain would be all reals except x equal -4, and then the range would be all reals except y equaling -8, because I have to take out that point, that xy point. All right, so looking at this one, I'm allowed to use all x's that are positive, so I get this part of the graph. And then I'm allowed to use x's that are negative, so I get this part of the graph. So here and here, so there's two parts to this absolute value graph. So the domain that I'm allowed to use is all reals, except I cannot use 0. And the range would be all real values. All right, so this one, notice I am not saying graph. This is not a basic graph. I'm just concerned about the domain. So I can see that the x's have to be bigger than 0. I can't have 0 in there because it's on the denominator. So the domain is just going to be the x's that are greater than 0. All right, so looking at another one of these where we're going to cancel. So if I see that this is going to be x minus 2, x plus 2, over x minus 2, cancel here. So I'm looking at the line x plus 2, except I cannot have x minus 2 equaling 0, right? That's the factor that I canceled out. So what that means is x cannot be 2. So just solving there. All right, so I've got the line y equal x plus 2. So this 2 is this 2, right? And where x cannot be 2, that's this 2 down here. And so that means I need to put a hole. And how do I know where the y value of that hole is? So I would put x equal 2 into here, and that gives me y equal 4. So that's the y value where that hole is. So what's the domain of this? The domain will be all reals except x cannot equal 2. All right, so this seems really similar, but it's a little bit different. So if I take and factor the denominator this time, I get 1 over x plus 2 left. Okay, so it's not a line, it's a hyperbola. And then remind yourself that what cannot equal 0, so x minus 2 cannot equal 0, so that means x cannot equal 2. All right. So let's first put together what the graph is. This is like the graph of 1 over x, and it's got a vertical asymptote back here at -2. So here and here is the graph. And then where is this hole? This is going to be when x is equal to 2. I'm going to have a hole in the graph. And if I wanted to find out what the y value of that hole is, I would use that into this function. So that would give me y equal 1/4. So that's the y value of that point. So what's the domain? The domain would be all reals except for 2. All right, so let's move on to some other important things of composition of functions. So if you're given the f and the g and you're asked to put these together, so f of g of x, you might have seen this before as fog, right? So that means you're putting g of x inside. And g of f of x is hardly ever the same thing. So this means I'm taking g and I'm putting f of x inside. So there it is. Let's play with some other trig functions. So f of g is going to be tangent with 1 over x squared. Inside is the angle. And g of f of x will be putting tangent inside the squared in the denominator. And that's a fine answer. I just want you to know it can be rewritten like this. So be able to recognize it both ways. So this time I'm going to ask you to create your own. So here is the capital F. I want you to make what the f and the g is, and f of x can't be x. That's too simple. So what's the outside function? What's the inside function? Really important to be able to do. So the outside function is e to the x. The inside function is 5x squared. This one could be done more than one way, but let's just go to this more straightforward. 1 over x being the outside function, g of x equaling x cubed plus 4. I want you to know that this is the same thing as saying secant of x all squared. So the outside function would be x squared. The inside function would be secant of x. This is the same thing as saying cotangent of x to the 1/2, right? I want to make sure you know that that's all inside the angle. So f of x would be the cotangent. The g of x would be the square root of x. All right, now 3 layers, f, g, and h. F, most outside function, then inside, then most inside. So ln of x I see is the most outside function. The next would be 1 over x. And then inside that would be x plus e. So again, let's make sure we see this cubed before I break it up. So let me make sure that you know this is the same thing as saying this. So this e to the x is on the inside. So it's not necessary. This is a fine way to write it, but I need you to know that the most outside function is x cubed. The next inside layer would be the cosecant x. And then the most inside would be e to the x. All right, let's look at this next one, f, g, and h. So the most outside function is cotangent of x, right? It's not necessary, but this could be rewritten as, right? If we wanted to really emphasize the parentheses, the next inside function would be ln of x, and then the most inside would be pi x.